Okay, Glass. What's up?
Hello, my name is Brian.
This is Mr. RIMP. RIMP stands for Robot in My Pocket, which is based on a movie called Angel in My Pocket, Andy Griffith. It's a very feel-good family movie. And let me turn this guy on. He's not saying ribbit. He's actually saying ready. Okay. And sometimes he doesn't work. Oh, wait a minute. Could you hand me my? How many people have done that, by the way? Thank you so much. And like I said, he's kind of my wife loves parrots. She likes YouTube videos. We don't own a parrot. I keep talking her out of it. And parrots sometimes cooperate. Sometimes they seem really intelligent, and sometimes they're not. Sometimes they're totally inane, but they're entertaining. And sometimes they won't cooperate. And so I have a random number generator in here. Sometimes I tell RIMP to do something, and he doesn't work. And that could be because there's a wire loose, or it could be a bug in the program, or it could be he's actually just he's playing the persona that I designed him to play. So now you can't see this, but there are little graphics of an 8x8 LED screen here. And sometimes it works. Okay, Glass. What's up?
Hello, my name is Brian.
Hello, my name is RIMP.
Okay, Glass. What's up?
Hello, my name is Brian.
A lot of distortion there, so I like to repeat it afterwards. Let's see what else he likes to say. Well, actually, I need to, there's a little buffer that needs to flush, so I need to kind of wait for a moment, which I'll fill with. He has a bunch of sensors. So this is a rangefinder right here. There's also an ambient light sensor and an accelerometer. Of course, we've got the buttons. I don't have the buttons wired up right now because I'm not really sure what I want them to do. But you can imagine, going up to a child and saying, introduce yourself, shake hands by pushing the button in the palm of the, hello, my name is Mr. RIMP. Okay, so there's a physical surface to generate. And you see in the back row, but there's like a little robot, and as he's talking, the robot is gesticulating. Okay, let's see if anything else happens here. Okay, Glass. What's up? Nothing. Okay, Glass. What's up? Snakes are cool.
Snakes are cool.
I like that. Okay. So now I don't want to be too gender specific, but let's say you know that this little girl really loves snakes. So I'm working on kind of a topic map. So you walk into a room and it'll talk about certain things, kind of probabilistically, a little network. Okay, it's basically for pediatricians, child life specialists, people in children's hospitals, to say ABC. I wanted to talk about the staff by name. And so I'm working on kind of a REST interface. Okay, so one of the chips actually synchronizes to the cloud, and you would upload a JSON document that has a set of phrases and a set of images. Okay, that's kind of the fun plus the technical. He's a platform. This is version 2. Version 1 was kind of the size of a shoebox, and it was blue. I went with the metal, because robots are metal. And my wife wants to, Mrs. RIMP or Ms. RIMP, maybe go back to blue. Okay. Version 3 is on its way. Version 3 will be half the size. Actually, if you looked inside RIMP, he's mostly air. There's all these little places where you stick the wire, the I/O pin bridges. If you take those out and solder them directly, I can get him down to about a half. Like I said. In fact, I want him to be small enough that he will fit into my pocket and be basically invisible, and then you can just pull it up, start him up, so forth. 3D printing. I'm doing my own 3D printer. I have my 3D printer in the car with me. Take it with me wherever I go. Working on them last night. So if I have an idea, I just print a new body, stick it on there. It's been an interesting design process. I am controlling it through Bluetooth Low Energy, and but there's kind of like three levels of design. Okay, there's all of the boards. Okay, so I've got the sensors, rangefinder, accelerometer. Oh, by the way, there's a little event loop with logic and rules, and so I can set it up so that, let's say, the next time something is 2 foot away, I want you to do certain things. So I walk in, child's face. He goes, "Oh, hello, who are you?" The ambient light sensor. I can go, okay, I can turn off the light and it'll go, "Hey, who turned off the light?" If I also have what I call, now I'm speaking a lot of this in the present sense, in the present tense. I'm always swapping things in and out to see what works, to explore what behaviors I can get. And so I never have everything all working at the same time. But eventually. But remember the ambient light sensor? Who turned off the lights? And, oh, hello, who are you? I have like a little I call it a sassiness level. It's a number between 0 and 10. It starts at 0, and it gradually gets higher. And as it gets higher, he starts to be louder and more raucous and more crazy. And when he gets to 10, he just like can't shut him up. Okay? But if you put your hand over, like to calm him, all of a sudden the distance goes to 0, and the ambient light goes to 0. So the rule says if the distance goes to 0 and the ambient light goes to 0, reset the sassiness level to 0. That kind of calms them down. Now, here's the serious part. My background is in workflow technology. I'm sort of Dr. Workflow on Twitter. I'm a proponent of what I call wearable workflow. What is wearable workflow? I want to plant a word in your brain, a candidate to become a meme. And the word is this: wearlet. A wearlet. What's a wearlet? Well, you remember applets? Java applets, they ran in web pages. You have portals. Patient portals can be constructed from portlets. You basically combine them kind of like Tinkertoy. And there's all kinds of things that end in LET. They're diminutive. They're small that you can put together. Well, eventually, I'm going to be wearing my Android Wear watch and my Google Glass and my Nike sneakers that are going to be intelligent. And I'm going to have something on my belt. And Google Glass, and then my, smartphone. Okay, and they're all going to be context sensitive, and they're all going to be reacting to movement, temperature, location, geofencing, and then they're all going to go off at the same time. Is actually having a workflow engine. Workflow is a series of tasks that consume resources, most notably in this case, attention, that achieve some goal. Okay? And so you could imagine, something happening on your watch, you watch something here, you pull out your phone, reply, so there's going to be kind of workflows where 3 or 4 things is going to happen in a row. And one of the great things about contextual computing, context-aware computing, is there's a nice fit with the machine learning. In fact, Google Now is always sort of trying to predict what we want to do next, as an example, but it's not always right. And machine learning algorithms, the networks, the neural networks and so forth that respond, are pretty opaque. They're hard to understand, they're hard to have a conversation with and say, why do you do that once you do something else? Okay? And that's where traditional workflow technology comes in. Workflow technology is you have a representation of workflow. It could be a picture of workflow. It could be represented in a JSON document. But it can be understood and inspected and edited by a human user. Now that workflow engine that affects the workflow, the wearable workflow, could be resident someplace. Okay, it could be here, it could be on the cloud. as a platform, this is kind of what I created RIM for. Okay, I'm interested in, I have an Arduino board at home that I wear with Bluetooth, okay? And it tells time by flashing. Okay, so, and it talks to RIM. I didn't bring it. But I say I have all these things that are communicating with each other, and they need to cooperate as a team effort to make my user experience, who is wearing all of these things, a good user experience. And I think the key concept is wearlet. Now, what's a wearlet? Well, a workflow is a series of steps. A workflow engine says, what's the next step? Okay, your turn, execute this, execute that. A wearlet is basically a software representation of the hardware functionality. So it's kind of like, I've got a watch, I've got RIMP, I've got something on my ankle. Hopefully it doesn't have anything to do with the justice system. And there's a representation in the computer of, okay, there's a thing on the ankle, there's a thing on the wrist. And here's a list of things it can do. And here's the list, and here are the contexts in which it will execute. And here are the sequences of workflow that are stereotypically needed by this worker. Okay? Bing, bing, bing. All the ones involved. Instead of words, those are the wearlets. Well, they are the wearlets. But the wearlets are just software wrappers for the hardware. Now, here's the interesting thing. A hardware wearable is multifunctional. Okay? So it maps to multiple functions. And the same function can map to multiple hardware wearables. So notification can happen on your wrist, in Google Glass, in your pocket, maybe even in your shoes, if you're card counting at Las Vegas. Anybody ever see that movie? So you're abstracting away from the hardware and thinking about not the wearable hardware itself, but the wearlet in terms of the function. And then you basically want the hardware, wherever, to make the right sound or vibration or whatever appropriately to achieve that wearlet purpose. Okay. And similarly, just like you can have multiple pieces of hardware accomplish the same thing, you can have the same thing accomplish multiple purposes. So there's a many-to-many mapping in this matrix between the hardware wearables, and the software representations. And then there's some kind of coordination. Now that coordination may be a set of rules that are propagated to each of the wearlets for such things as contention management when they all want to go off at the same time. Or they may be more centrally coordinated in the cloud, in here. I'm kind of reminded of some of the video that we saw where Paul said that you don't want people saying, okay, Glass. You want it just on and some central coordinator. So, if I have accomplished my purpose, there are two parts of the purpose. One purpose is to entertain you, and the second purpose is to insert into your brains a meme, which is the word represented by the word wearlet, because you construct wearable workflows out of wearlets. Thank you very much. And I'll take any questions.